Hello everyone. In this video, we will be discussing a few more numericals from Springs part. So already in the previous videos, we have discussed two numericals. Of course, both the problems are different. So again, the same rule is applicable for this video also. If you want to learn this problem or if you want to solve similar type of problems in your examinations, means definitely you should be prepared with the basic concepts of springs and even the derivations of the springs, particularly the helical coil springs, stress for circular and non-circular, and about belly springs you should be having some idea, and the leaf springs also you should be having some idea. And because when we discuss those topics, some shear stress derivation and even some power derivation, stress derivations, so all those things we have discussed. And even we have discussed one important concept, that is wall stress factor, spring index, all those things we have discussed. So if you want to remember the concepts, or if you want to solve any type of problems in springs, means it is mandatory to know the fundamentals of springs. So now I'll be discussing a problem from spring, and I have taken this question from VTU prescribed textbook, design of machine elements, and author is VK Bandari. So let us discuss the question first. So a wagon weighing 50 kilonewton moving at a speed of 8 kilometer per hour has to be brought to rest. Okay. So there is a wagon and it weighs 50 kilonewton, and this wagon is moving at a speed of 8 kilometer per hour. It can be a like a kilometer per hour means it is actually like a velocity. We can able to convert this kilometer per hour as velocity. So we know that velocity unit is meter per second. So kilometer we can convert into meter, and hour we can convert into second. Has to be brought to rest. Springs made of wire of diameters 25 mm with a mean diameter of 250 mm. So here they have mentioned that they didn't mention the spring material. Instead of that, they have mentioned. So only material is not given, but instead of that, they have mentioned the wire diameter and even mean diameter. We know that wire diameter, if they have mentioned, means the spring cross section is circle. Very clearly we can understand. And mean diameter value they have given. So that is capital D, that is 250 mm, and with 24 turns are available. So the totally in springs, and they have not mentioned what is the number of active springs, I mean active coils and all, they didn't mention. Instead of that, 24 turns are available, they mention. So we need to find out the number of springs required in the buffer to stop the wagon at a compression of 180 mm. Okay, and the rigidity modulus value given as 84 gigapascal. I think the question is very clearly given, and we need to find out the total number of springs required to stop the wagon, and all that load value, speed value, everything they have given. We will see how to solve this problem. So first we will write down the given data. So the given data they have given, anyway the load is fine, that is fine, but they have given the speed. As I said, when you look at the unit, it is kilometer per hour. So kilometer per hour means definitely it's supposed to be a velocity. So as I said, we need to convert kilometer to meter. So kilometer to meter means we need to multiply with 1000, and hour to seconds. So 1 hour is having 3600 seconds. So 8000 divided by 3600. So velocity we will be getting as 2.22 meter per second. It is again still it is in meter, and we need to find out kinetic energy. Since it is the wagon is moving, so it is under motion. So the kinetic energy formula is half mv square. So I will be writing 1 by 2. M value, it is 50 into 10 power 3. The value is given, and the gravity also they have given, since we are substituting the mass. So 9.81, since the weight is given, so 15 to 10 power 3 divided by 9.81, and the V value is 2.22, so it is square. So I will be getting kinetic energy, since I am substituting kinetic energy in terms of meter, and similarly the velocity also in terms of meter, so meter get cancels, and finally I will get the kinetic energy after simplification as 12.6 into 10 power 5 Newton mm. Next, I need to find out the deflection. So the deflection formula is 8p d cube n divided by gd power 4. So here if you see means the deflection value you can able to see like wagon at a compression of 180 mm. It is like it is the displacement. You can able to see the 180 mm is the thing, but the displacement that we can call it as a deflection. So 180, that is the deflection, which is equal to 8 into, since we do not know what is the P and D value is known, that is 250, and power value N is nothing but 24, and the rigidity modulus value it is 84 gigapascal, so 84 into 10 power 3, and diameter of the wire value is 25. So substituting all these value, so the P will be the unknown. So after simplifying, we will be getting the P value as 1968.75 Newton. And moving to the next one, work done. So the formula is 1 by 2 into P into delta. So here you can able to see we know P value and even we know delta value, which is given in the question itself. So after substituting the P and the delta value as 1968.75 and 180, we will be getting the work done as 0.18 into 10 power 5 Newton mm. You can able to see the kinetic energy also I am getting in terms of Newton mm, and similarly the work done also I am getting in terms of Newton mm. So why we need to find out kinetic energy means, because here we are in the process of finding out number of springs. So the number of springs is nothing but kinetic energy divided by the work done. So this is a note formula which is not available in the data handbook, but the work done formula and the deflection formula is available in the data handbook, but the number of springs formula which is not available, which we supposed to remember as a note. So the kinetic energy magnitude is 12.6 into 10 power 5, and the work done is 0.18 into 10 power 5. So I will be getting the solution as 70. In case if you are getting your answer in terms of decimal, say for example 69.3 or like 70.2, means you can round off to the next immediate number. So this is how this problem should be solved. We will move to the next question. In springs, again this question is taken from Design of Machine Element VTU prescribed textbook, and author is V.K. Bandari. So the question given here is, a closed coil helical spring is made out of wire of 6 mm diameter with a mean diameter of 80 mm. What axial pull will produce a shear stress of 140 megapascal? If the spring has 20 coils, how much the spring will extend under the pull? Rigidity modulus given as 80 megapascal, and what work will be done in producing this extension? Okay, this is almost very similar to the previous problem, except a small change of data. So first let us write down the given data. Wire diameter is 6 mm and mean diameter is 80 mm. Spring index value, since we know capital D and small d, we can able to find it out. The spring index value as 80 by 6 is 13.3. So it is instructed not to round off the spring index value. Go with the same value whatever we are getting. So first let me find out the constant K value, that is 1 plus 1 by 2C. So since the C value is known, by substituting we will be getting the K value as 1.0375. So first next let me go to the shear stress formula, which is nothing but K into 8PD by pi d cube. K value is known, P value is unknown, D value is known, and small d value is also known. By substituting all these values in the given formula, we can able to find out the P value, and I am getting the P value as 143 Newton. Next, moving to the next one, deflection. So deflection formula also we have discussed in the previous problem. It is 8P mean diameter cube into N divided by G into D power 4. That is the wire diameter power 4. All the data are known. Even the P value, just like in the previous step only we found out. So by substituting the P value as it is, we can able to find out the deflection, and the value we are getting is 113 mm. So finally work done, because that is the thing asked. So what work will be done in producing this extension? So the work done formula is 1 by 2 into P into deflection. So P value is also known, and even the deflection value is also known. By substituting P value and D value, delta value, we are getting the work done value is 8079.5 Newton mm. So unit for the work done is it's Newton mm. So these problems are sufficient to solve spring problems, because it almost covered all the applications. Belly springs, with the washers, and even the leaf springs. So everything, all the types of problems almost to be covered. So with this, the spring concepts gets winded up. Thank you.